So we are going to take the inverse algebraically of these two functions. So we have f of x and g of x. So when I write the inverse, I'm going to use what looks like a -1 exponent, but it is not really an exponent. It is a sign, a symbol showing us in math language that, hey, this is the inverse of our original function, g of x. Now, in number one, to find the inverse, one thing I like to do is I like to replace our function name with y. So I just say y equals the cube root of x plus 4. And then what I do is, I don't know if you remember when we did this graphically, but when we do this graphically, you flip your x and y coordinates. So in the same way, when you do this algebraically, you're going to flip your x and y's and solve for y. So instead of y equals, it becomes x equals the cube root of, and instead of x plus 4, it becomes y plus 4. Now from here, once I solve for y, that is my inverse. So we'll rewrite it, instead of y equals, we'll rewrite it as f inverse of x equals. But how do I get rid of a cube root? Well, I have to cube it. So whatever I do to one side, I have to do to the other side. So if I cube this entire right side of the equation, I have to cube the entire right side of, or the left side of the equation. So this becomes x to the third equals, now a cube root and a cube, they simplify to be 1. So we're just left with what's underneath the cube root, which is y plus 4. Then solving for y is not a big deal. We're going to subtract 4 from both sides. Those are not like terms, so I'm just going to write them beside each other. So I have x to the third minus 4 equals y. Now, some people don't like having it written that way, so you might want to just write y equals x to the third minus 4 to make it look similar to what you're used to. But from here, I told you that this is our inverse. So I need to rewrite this. Instead of y equals, I'm going to write the inverse equals. So I'm going to say f inverse of x equals x to the third minus 4. So given my original function f of x was the cube root of x plus 4, its inverse is going to be x to the third minus 4. Now, number 2, not only are we going to find the inverse, but we're also going to find the domain and range. Now, you may think it's actually going to be easier. You may find it'll be easier to find the domain and range first. So let's go ahead and do that. So I want to go ahead and find the domain of this square root function. Now, domain here, the only domain restrictions are where is this going to not be a negative. And so we want this to be greater than 0. And so what we're going to do is we're going to take our 2x plus 4 and we're going to set that to be greater than 0. And then solve, and that'll give us our starting point for our domain, our first x value, the lowest x value we can have. So after I subtract 4 from both sides, I get that 2x has to be greater than -4. And once I divide both sides by 2, I get that x is greater than -2. So this is my domain. We're saying that my domain has to be any x value that is greater than -2. So starting from -2 all the way out to the right. Okay, so from there, what about range? Now remember, square roots start at the origin, and so there is no shifting up or down. So actually, in this case, my range is all of my y values that are greater than or equal to 0. So it can be equal to 0. So remember, the parent function would just be the square root of x. So when x is 0, y is 0. So range represents the y values. So y can equal 0, and it can be any number greater than that. Now, this is the domain and range of my g of x. So maybe I'll make a note here that this is actually just g of x, domain and range. We're going to then take a look at why I would do that first before finding its inverse. So let's go ahead and take a look at that right now. Now, I told you in this previous problem that instead of writing g of x or whatever, I'm just going to write y. So I'm going to say y equals the square root of 2x plus 4. And then remember, just like graphing, we're going to flip our x and y. So this becomes x equals 2 times y plus 4. From here, you're just going to solve for y. I forgot the square root. So you're just going to solve for y. So similar to our previous problem, How I undo a square root is by squaring both sides. So I get that x squared equals what is underneath the square root, so 2y plus 4. So square root with a square, simplify out to give us a 1. And then solving for y. So I'm going to subtract 4 from both sides. So after I subtract 4 over here, again, those are not like terms, so I can't combine them. So I'm going to write them out right next to each other. X squared minus 4 equals 2y. Now you want to be careful here. It doesn't really matter. You can leave it as one full fraction if you'd like, or you can write your fraction individually for both terms. I'm going to go ahead and just leave it as one full fraction for today. And so whatever I do to one side, I have to do to the other. So I'm going to reflip my order. So I'm going to say that y equals, my numerator is x squared minus 4, and this is all over 2. Or instead of y equals, this is actually g inverse of x equals x squared minus 4 all over 2. Now we needed to find domain and range of g inverse of x. So g inverse of x, domain. Remember how we said we just flip x and y. So my domain of my inverse is going to be the same as the range of my original, because you're flipping your x and y. Remember how domain represents x values and range represents y values? So if my range in my original function was y is greater than or equal to 0, then my domain of its inverse is going to be x is greater than or equal to 0. If my domain in my original was x is greater than -2, then my range in my inverse is going to be y is greater than -2. So those just get flipped around. So if you ever need to find the domain and range of an inverse function, if you can find the domain and range of your original, then finding the inverse is very easy because they are just going to flip.